Welcome to another explainer. So if you've ever looked at a blank black screen with flashing green text and thought it looked like something straight out of the Matrix, well, you are in the exact right place. Today, we're taking all the mystery out of the Cisco Internet Work Operating System, or iOS.
It's a pretty massive question, right? I mean, how do we actually control the devices that power the entire internet? Spoiler alert, it's not through fancy touchscreens or virtual reality headsets. Today, we are going to look at the exact tools and commands technicians use to manage the global network's secure fortresses. We're going to see exactly how the pros get under the hood of routers and switches.
Here's our roadmap for today. First, the operating system core. Then, accessing the device, navigating iOS modes, and finally, deciphering command syntax. Let's get right into it.
All right, Section 1, the operating system core, inside the machine.
Okay, think about basically any computer out there, network switches included. At the dead center, you've got the hardware, right? The physical electronics. Wrapping around that is the kernel, which acts as the grand communicator. It tells the hardware how to actually use its resources to meet the software's demands. And finally, on the very outside is the shell. This is the user interface. It's what allows us to request specific tasks. So the physical hardware relies entirely on the kernel to talk to the shell, which is where we step in.
Now, how we actually interact with that shell completely depends on the job. Most of us are super used to graphical user interfaces, GUIs, like Windows or Mac OS, where you just click around with a mouse. But network pros, they live in the command line interface, or CLI, where you use a keyboard to enter text-based commands directly into the system.
You might be wondering, why type when clicking is just easier? Well, it's all about control and absolute reliability. GUIs are great, but they can crash or freeze up, and when you're configuring a switch that handles critical internet traffic for thousands of users, yeah, a screen freeze is literally not an option. The CLI is lean, mean, and practically bulletproof.
Moving on to Section 2, accessing the device, finding the front door.
So, you generally have three main ways to actually get into a Cisco device. First is your physical console connection, perfect for that initial out-of-the-box maintenance. Second, we have Secure Shell, or SSH. This is absolutely your go-to method for everyday use because it builds a highly secure, encrypted remote connection. And then there's Telnet. Telnet is, well, it's older and it literally sends your passwords over the network in plain text. So, yeah, definitely avoid that one in a modern environment.
Let's zoom in on that physical connection for a second. That iconic light blue console cable is literally your key to the front door. See, when a switch is brand new, it doesn't even have an IP address yet. You can't just remote into it. You actually have to physically plug this specific cable into the device's management port to get the whole thing started.
But just plugging in the cable doesn't magically do the work. To actually type your commands, whether you're using that blue cable or connecting remotely via SSH, you need terminal emulation software. Industry heavy hitters here include PuTTY, Teraterm, and Secure CRT. These programs basically give you that classic black window where the CLI lives, letting your keyboard talk directly to the network hardware.
All right, Section 3, navigating iOS modes, security clearances. Okay, think of the iOS like a highly secure facility. Step 1 is user exec mode. That's basically the lobby. You can look around, do some basic monitoring, but you can't touch anything. Step 2 is privileged exec mode. Now you're behind the reception desk with full access to all commands and features. And Step 3, global configuration mode, puts you right in the main control room where you can actually make changes that affect the whole device.
What's really cool is how this system uses simple prompt symbols to let you know exactly what your clearance level is at any given moment. If you see switch followed by a greater than sign, you're safely in user exec mode. You can't break anything there. But if you see that hashtag, you are in privileged exec mode. You've got the keys of the castle now, so you definitely need to be careful with what you type.
And it goes even deeper. Once you hit global configuration mode, which you'll spot because it says config in parentheses, you can dive into specific submodes. You might go into line configuration to secure your console access, or interface configuration to control just one specific network port. The prompt actively updates in real time to show you exactly where you are, like config line or config if.
So how do we move between these security levels? With specific passphrases. Typing enable from the lobby gets you privileged executive clearance. From there, typing configured terminal drops you into global config. If you want to back up a single step, just type exit. And if you're super deep into submode and just want to bail all the way back to privileged executive instantly, just type end or hit Control Z.
Once you get the hang of it, the flow is super logical. Which brings us to Section 4, deciphering command syntax, speaking the language.
Okay, so every single instruction you give follows a very strict structure. First, you have your prompt showing your current mode, then your base command, a space, and finally your specific keyword or user-defined argument. Just remember, a keyword is a specific parameter the OS already knows, while an argument is a custom value you provide yourself, like an IP address or a new host name.
Now, when you're looking at Cisco documentation or help files, you absolutely have to know how to read their syntax maps. It's actually pretty straightforward. Bold text means you type that word literally, exactly as it's shown. Italics, on the other hand, mean you need to plug in your own specific value. You don't actually type the italicized word itself, you replace it with your own data.
And the punctuation is just as important because it tells you what's mandatory. Square brackets are basically a cheat sheet for optional parameters. You don't have to use them for the command to work. But curly braces, those indicate a required element. It is an order you absolutely must give the system. And if you see vertical lines inside those braces, it means you have to choose one of those specific options. It's kind of like a mathematical formula for network control.
And there you have it. We started at the absolute basics of the OS layers, grabbed our blue console cable to get physical access, navigated the security clearances, and broke down the command syntax. You now possess the map to access the literal core of the Internet's infrastructure. It's pretty wild to think about, right? One command can secure a digital fortress, and one typo could take down a whole network. So, the command line is waiting. How will you shape the grid today? Thanks for joining me on this explainer, and keep exploring.